We're asked to find the volume of this pyramid. So what we want to do, if we want to do it a calculus way, is to come up with a formula for every square slice we could take out of this, every two-dimensional slice. And then when we integrate it, that brings a two-dimensional object into a three-dimensional calculation. Okay, so we want to create the formula for the area of a square, and then we'll integrate it from 0 to 9, because that's the height. So let's superimpose this on a two-dimensional x and y grid. We'll just use 0 as the starting point, 9 as the ending point to make it easy. So this is a two-dimensional representation. And if we're trying to find a formula for this square, it's 3 on the bottom, but it's smaller. It might be like 2.5 for a side length if we take this slice, or maybe it's 1 at this point when we take that slice. So we need a formula for the slices that we make. So we'll call this x, this distance from here to here. And then this distance from here to here at the very bottom, it's not 3. That would be all the way across. This distance is 3. So this distance right here is 3.5. So we've got this big triangle, and then we've got this smaller triangle that we're dealing with, right? They're similar triangles because one's inscribed inside the other. So we can come up with a formula for x by giving this other part of the similar triangle a variable, because we don't know what this distance is going to be when we're, say, halfway up. So we'll call that y. And then we can use the fact about similar triangles, how we can compare them to one another. We can make ratios of the corresponding sides. So the bigger side of the triangle, divide by the, I guess we don't know which one's bigger or smaller at any point. So we'll just say the horizontal side of the big triangle, divide by the horizontal side of the smaller triangle. That should equal the vertical side of the big triangle, divide by the vertical side of the small triangle. And remember, we're trying to come up with a formula for this, for x. So we want to solve this equation for x. I'll multiply x to both sides. And then I'll multiply both sides by y over 9. And then just simplifying that fraction, that's y over 6. So now we have a formula for half of the side length. The formula for the two-dimensional area of any slice that we take, this is y over 6 when we're halfway through, so we just need to double it. This entire side length would be y over 3. Okay, we do y over 6 times 2, that makes y over 3. Okay, so the side length of any square is y over 3, so we want the area of the square, so we just need to square the side length, because it's length times width. Y over 3 times y over 3. So that's y squared over 9. Okay, so that's the area of each slice. That's what we want to integrate. Starting at y equals 0, starting at the bottom of the y-axis that we drew here, all the way to y equals 9, we're integrating y squared over 9 with respect to y. So we can factor out that 1/9 to make it a little easier. And then that's a pretty easy integral. That's y to the third over 3. And then if we plug that in, that's well, we're going to have a 9 on the bottom and a 9 on top. So that's 9 squared over 3. So that's 81 divided by 3. So that should be 27, right? Let me double check. I think I already did it when I was looking at this problem before. Yep. Okay, so that's our volume, 27.